Hey guys, it's Stratton. I wanted to take a minute to go through the FRQ rubric so that you can score your FRQ you did this last Friday. So question number 1 was about trichomes. So those little hairy outgrowths on the epidermis of plants that possibly protect them against herbivores. And so there were, again, 3 populations, 6 plants in each population. They measured the mean and they calculated the standard error of the mean. And then there was a graph given to you. The original version of this question had you make the graph. Obviously, you can't do that on your phone. So we're going to skip that for now. So based on this graph then, which 2 populations are most likely to have a statistically significant difference between the mean trichome densities? So first thing is you get a point for identification for just saying populations 1 and 3. And then you get a point for justification. The justification comes from probably the fact that the error bars do not overlap between population 1 and population 3. Could have also said that there's a difference, that the sample mean plus or minus the 2 SEMs are different, but probably went with the error bars. Okay, part B of this question is asking you to talk about an experiment that you would design to check the effect of trichome density and herbivory. So there's 2 different ways you could go about this experiment. So experiment number 1 would possibly be, and you would be getting points for each of these boxes across one of these rows. So your independent variable, again, independent variable is the thing that I change. So presence of herbivores. So you would say, hey, I'm going to put herbivores in with these plants. And then dependent variable thing you're going to measure would be trichome density. So in other words, how does the presence of herbivores affect trichome density? Your control, no herbivores. So just plants by themselves. Duration is just more than 1 generation. So whatever it takes for these plants to reproduce at least once. And then prediction, that you would find more trichomes in the ones that were subjected to herbivores rather than your control, which didn't have herbivores. The other way you could approach this would be sort of backwards. You could use different plants with different numbers of trichomes. And then you could, so you'd have a group that had, in other words, really heavy trichome density, another one that would have much lower trichome density, and you would introduce herbivores into those situations. And then you would measure reproductive success. That would be the dependent variable. Again, you're going to have a control. That would be the ones with lower trichome density. And then the duration would be more than 1 generation, same thing. And then what you'd find is the population that had higher trichome density probably is going to have greater reproductive success. So in other words, they're going to produce more seeds, or however you're going to measure this. Okay, so that was question number 1. Question number 2 is about bromelain, which is an enzyme found in pineapples, which is a protease. It breaks down proteins. So the first thing was identify the type of monomers of which this enzyme is composed. So it's an enzyme, it's a protein. It is made of amino acids, 1 point. So bromelain works by breaking the enzymes into smaller molecules. How does that work? Well, there's 2 ways you could say this. You could just simply say, hey, it's a hydrolysis reaction. It's going to break down the enzyme, break apart the amino acids. Or if you didn't remember the name of hydrolysis reaction, you could just say, hey, you know what? It's going to break the bond between the amino acids. Peptide is optional. It's in parentheses. You do not have to say the word peptide. But if you say it's going to break the bond between the amino acids using water as a reactant. So something in there about adding water into that reaction. You could say it adds a hydroxyl group to one side and a hydrogen to the other and breaks apart the amino acids. It's obviously just easier if you remember the word hydrolysis. Okay. And then part C, the pH of the solution. It determines the charge of the R groups. The pH of pineapple fruit is from 3.5 to 5.2. Predict the effect of the activity of bromelain if used in a pH of 11. So your prediction should be, hey, you know what? It's not going to be as active. It's going to decrease. It's not going to break down as much protein, something along those lines. And then your reasoning, so your justification here would be something about the pH is altering the interactions or the bonds and the bonds, whatever, between the R groups, and that's changing the shape or folding of the active site of the enzyme. So you do not have to say active site. You could just say it changes the shape of the enzyme or the folding of the enzyme, but that's really what it boils down to. So 4 points there. So what I'm going to have you do is go on to the Google form that I'm going to provide you a link to and put in your score on these 2 questions. Question 1 out of 7, question 2 out of 4. Okay, and I will see you guys later.